Hi, good morning everyone. My name is Nobel Perwira, and today I am excited to share the findings of our study titled Analysis of Four-Story Factory Building Using Special Moment Resisting Frame System or SMRF with and without Prestressed Post-Tension PT One-Way Slab and Beam. This research was conducted under the guidance of Dr. Nur Aziz Handika, Dr. Jessica Sjah, and Mr. Indra Nuruddin Fatoni from the Civil Engineering Department at Universitas Indonesia. Let's start by setting the context. Seismic prone areas demand buildings that balance safety, efficiency, and sustainability. However, traditional SMRF designs often require large amount of concrete, reinforcement, and also formwork, making them expensive and resource-intensive. This study investigates whether the use of pre-stress post-tensioning systems or PT systems combined with SMRF can enhance seismic performance while reducing material costs. Our objectives are twofold. The first one is to evaluate whether PT improves seismic resilience, and the second one is to assess whether PT reduces material usage without compromising safety. Now let's talk about the background on PT and SMRF. SMRF is widely used for its excellent lateral resistance and ductility, essential for buildings located in high seismic activities. Its rigid beam column connections handled high seismic loads effectively but require extensive material, limiting its sustainability. In contrast, PT systems minimize structural dimensions and reinforcement, mitigate cracking, and extend life service. When integrated with SMRF, PT offers promising potential for industrial buildings in Indonesia, where its adoptions are still limited. Now let's talk about the methodology of this research. For the methodology of the study, we explored three design models for this analysis. The lateral resisting system is highlighted on the red on the 3D model. The first one is M1, the conventional SMRF with two-way slabs across all beams and portals. The second one, M2, is a PT one-way slab and beams with SMRF on the perimeter and the central portal. Once again, the SMRF is highlighted as the red colored. The last one, M3, is pretty similar to M2, but includes shear walls for additional stiffness located on the perimeter of the buildings. Using ETABS version 21 and the response spectrum method, we designed these models to meet Indonesia's seismic standards. Each designs underwent iterative adjustment using capacity-based design to ensure compliance and the optimization of the performance. Now let's talk about the parameters used in this study. For our seismic analysis, we considered the spectral accelerations for Depok, a region prone to seismic activity. It is also the location of Universitas Indonesia. Parameters used are as shown in the table. M1 and M2 model are considered as SMRF, while M3 model is considered as dual system, meaning that they will have a different modification response coefficient, stronger system factor, and deflection amplification factor. Also, take note on the spectral descent acceleration. The spectral descent acceleration for the short period is 0.72, and the spectral descent acceleration for the 1 second period is 0.67. Now, let's dive into the results about the structural response. First one is the story shear. The story shear of the M2 model is reduced by 7 to 13% in the x-axis and 6 to 9% in the y-axis, while M3 model shows an increase of story shear ranging from 1 to 9% on the x-axis and 6 to 14% on the y-axis. This increasement on the M3 model happened because of the shear wall, because the shear wall absorbs more seismic forces. Therefore, it increases the story shear. Now, if we talk about the drift of the building, the drift of the buildings is reduced significantly. M2 model has a 55 to 73% of drift reduction on the x-axis and 24 until 44% drift reduction on the y-axis, while M3 model uh, has a greater drift reduction. up to 86% on the x-axis and 83% on the y-axis. Now, this greater drift reduction also happened because of the existence of the shear wall on the M3 model. Because there is a shear wall, that's why the building could resist more drift. These results confirm that both PT models, M2 and M3, managed to outperform the traditional SMRF in lateral resistance. Now, we are going to discuss about the material usage for each model. Material usage is also an important factor because the lesser the material usage, the greener, the less CO2 emissions, and the cheaper the building will be. When it comes to materials, both M2 and M3 models also showed remarkable savings. Concrete usage was reduced by a similar amount on both models, approximately 373 cubic meter. Rebar requirements or reinforcement requirements also dropped by a similar amount on both models, approximately 624 tons. Once again, the formwork usage also decreased, saving around 11,000 square meters of formwork. Now, the majority of these savings came from the fact that both M2 and M3 model don't have any secondary beams. Remember, because it's a one-way slab system, unlike the first model, the M1 model, which is a two-way slab system. Even though most of the column and the primary beams are enlarged on the M2 and M3 model, the reducement still far exceeds the increasements of the dimensions. Since M2 and M3 model has prestressed element, therefore it has tendon needs of around 11,000 kg of prestressing steel. After we discuss about the material usage, let's talk about the cost analysis. The cost analysis is calculated with the unit price based on the provisions of the Indonesian Ministry of Public Works and Housing Regulation. The unit price in Indonesian is called AHSP. Cost-wise, the traditional SMRF model or the M1 model was the most expensive, at roughly 49.878 billion rupiahs. M2 model cost 43.008 billion rupees. M2 model emerged as the most economical option, saving roughly 13.77% in cost. Now, M3 model cost 43.139 billion rupiahs, saving only 13.51% in cost. While slightly more expensive than M2 model, remember, M3 model offered a superior structural performance due to the due to the shear walls. It has less story drift. Now, these findings highlight the economic and the structural advantage of, of incorporating PT systems on a factory building, especially in Indonesia. Now, what is the key finding, conclusions, and the future works of this study? In summary, our study demonstrated these things. The first one is that both PT models M2 and M3 significantly outperform traditional SMRF, reducing drift and displacement, meaning it enhanced the seismic resilience of the building. Number two, material efficiency was achieved with reduced concrete, rebar, and also formwork. This means that the PT models would produce less carbon dioxide emissions. Therefore, it is a greener option than traditional SMRF. Number three, economically, M2 was the most cost-effective model, saving around 13.77% of cost. While M3 offered a little bit less savings in cost, it has a better structural performance than M2 or M1. This might be more important if the design approach is using performance-based designs rather than the capacity-based designs used in this study. Now, the practicality of this study supports the broader adoption of PT systems in high seismic industrial buildings across not only Indonesia but across the globe. As the next step, we suggest exploring more advanced seismic analysis, such as nonlinear or even time history methods, to validate the findings even further. Additionally, alternative PT configurations can be investigated to enhance the seismic efficiency and cost efficiency even more. These are the references used in this study. Thank you so much for your attention. I hope this study will be helpful in one way or another for you. I am happy to take any questions you may have. Good morning.